Thank you for attending and welcome to the 2023 Minnesota Air Quality Information and Outlook. I'm Matt Tarleton, the supervisory meteorologist for the Risk Evaluation Air Modeling Unit, which is the unit that forecasts air quality information for the state of Minnesota at the Minnesota Pollution Control Agency. This presentation will last about 20 minutes and cover these three topics: the Air Quality Index, or AQI, the 2022 air quality season and changes coming in 2023, finally, the outlook for the remainder of 2023. Please keep your mics muted and camera off during the presentation. There'll be time for question and answer at the end of this. Today marks the second day of Air Quality Awareness Week. Today's topic is asthma and your health. Please follow at MPCA or at MNPCA_AQI for the most information, as well as the Department of Health at MN Health for more information. To start off with this presentation, I'll talk about the Air Quality Index, or AQI. The AQI is basically a standardization of two types of pollutants, ozone and fine particulate pollution, which would be PM2.5. The AQI is broken up into several color scales, with green and yellow considered to be acceptable and orange and higher considering to be unhealthy, at least for sensitive groups. MPCA will issue air quality alerts if that AQI goes to orange or higher. At orange, starts at AQI of 101, members of the general public who have underlying health conditions, as well as the elderly and children, will be susceptible to the impacts of fine particle and ozone pollution. As the concentration goes higher, red, purple, and maroon indicate conditions that are unhealthy for everyone, with purple and maroon being very unhealthy to hazardous. In terms of forecasting air quality, the way we forecast air quality is mainly by starting with meteorology, but there's really three pillars that we look at to really make the AQI forecast. First is meteorology. We're looking at the standard weather variables such as wind, sky cover, relative humidity, frontal positions, and low and high pressure systems, as well as fire weather conditions. This is where we spend most of our time understanding where the meteorology setup will be and how that will influence the likely dispersion and creation of air quality pollutants. Atmospheric chemistry is another set of variables we have to consider, because many of the processes in the atmosphere have backgrounds in atmospheric chemistry. For instance, the formation of fine particles and ozone, you need different types of chemicals in the atmosphere before they'll form, either nitrates or volatile organic compounds, which we call VOCs. Keeping those concentrations into account, as well as the source region of the air mass that's over Minnesota, are all important characteristics to view when creating an air quality forecast. Finally, the third pillar is one that we can't really control and we have a hard time quantifying, but human behavior impacts. Air quality is unique in that humans can influence what happens. And so on days when we have an air quality alert and people work from home or take public transportation, we have a decrease in vehicle emissions, and that can actually improve air quality and make it not as bad as it would have been otherwise. Corollary, recreational fires and prescribed burns are human behaviors that can impact air quality. For instance, on the warm summer nights in early summer, we'll see PM numbers will spike when people have backyard fires, which is very common in Minnesota. Those types of activities can impact the air quality, and on days where we have air quality alerts can make them worse. In terms of how we issue air quality alerts, we use Geographic Information Systems, or GIS, to draw maps of the counties that will be in the air quality alert. Those counties are shaded orange by default, and then we will go in and add extra colors to the map if it is higher than an orange alert. Orange has the default air quality alert messaging, but is the other categories from red and higher will have refined wording and have highlighted impacts of what is expected with those concentrations. We've revamped our press release in 2022 that goes out to local broadcast media. That press release has improved wording about the impacts of air quality, and this was done in conjunction with the Department of Health, as they're the subject matter experts on creating health impact messaging. Finally, we initiated in 2022 a policy of press briefings for red or unhealthy for all or higher categories. This was in response to the 2021 season, and next time we have a major air quality event, we will host a press briefing where the press can ask questions, and these will be on days with red or higher air quality, so impacts to all people. The AQA product, which is the air quality alert product that the National Weather Service disseminates, is generated at the Minnesota Pollution Control Agency using a Python script. We then send those files over to the National Weather Service, and they are then disseminated. The AQA wording was already changed in 2022 to have the National Weather Service's where, when impact format. This means that the text format of the alert that goes out will be the same as other warnings that are issued by the National Weather Service. We also segmented out the alert so that our URL and information about our website are removed, and that makes the alert more easily disseminated on NOAA Weather Radio. And that was an ask from the National Weather Service. We also refined the wording so that different categories of AQI will have different wording in the alert about the impacts. This again wasn't done in tangent with the Minnesota Department of Health and highlights the most likely groups of people to be impacted, as well as what people can expect in the alert area. Finally, in 2023, we've decided to refine the call to action statements, and we'll now have a call to action statement to reflect what people can do to reduce their contributions to poor air quality. This was done in response to requests from partners and from the public, and we'll now highlight that when we issue an alert. Our alerts currently look like this, and this new call to action statement will go in the precautionary and preparedness action section, calling for people to reduce or eliminate activities that contribute to air pollution, such as outdoor burning and use of residential wood burning devices. Reduce vehicle trips and vehicle idling as much as possible. These are already tips that we've given out that are on our website, and also what the Department of Transportation will highlight when they light up the highway signs. And so this just reinforces what people can do to help improve air quality situations, or at least limit the impacts that your behavior will have on the air quality. Pivoting now to 2022 and early 2023, an overview of events. And this right here is our forecast for 2022 that we made in 2021. The forecast was for 3 to 5 ozone days. Some smoke impacts appear likely. This was our original forecast, and this almost came true, except for the fact that we had persistent smoke overhead for most of the summer of 2022, and that actually limited the formation of ozone. So this is our list of air quality alerts in 2022, and you can see there's nothing here. So in 2021, we had our worst air quality season with the most air quality alerts, and now in 2022, we had a season with no air quality alerts, our best season. This was caused by persistent haze for most of the summer. This was caused from wildfires in the southern plains and the northwestern part of the United States. Haze and smoke moved over Minnesota on the upper parts of the atmosphere, and that actually precluded the formation of ozone because it was so dense. We also had a drought develop and expand in central and southern Minnesota. That created the situations where we could have had fires, but thankfully we did not. And finally, we did have some air quality impacts due to thunderstorms, which derechos, which are widespread, long-lived damaging windstorms. We had a couple of them in southwestern Minnesota, and they were strong enough to loft dust off of fields. Our air quality sensors picked that up. We did not issue an alert, but it was something that elevated particulate matter almost to alert criteria, which was the first time we've seen that in Minnesota. Major fires across the United States are illustrated here. These are from the U.S. Forest Service. Every one of these red points represent a fire of 1,000 acres or more. You could see Minnesota didn't have anything around it. In the source region, most of the summer was westerly flow, which brought smoke in from the northwestern United States, and southwesterly flow, which brought smoke in from the southern plains. By the time those smoke arrived from those two fire areas, it was elevated well up into the atmosphere and came over Minnesota basically as a haze. This haze was so thick, it prevented solar radiation from getting down to the surface, which cooled our temperatures a little bit and limited the formation of ozone. So it busted our forecast. We did not have those ozone days. That was because that smoke was so thick, it limited the amount of solar radiation that we needed to generate ozone. So we were expecting a hot and dry summer, which would favor ozone. Instead, we saw a cooler summer with persistent haze, and that persistent haze precluded the formation of ozone here in Minnesota. It's worth pointing out that Illinois and Wisconsin were both impacted by the same air masses, but the smoke was able to get down to the surface, especially in Wisconsin, and that helped contribute to red air quality days along Lake Michigan, which is unusual for ozone. The smoke was elevated over Minnesota, and the only thing that stopped us from being impacted here in the state was pure luck. The meteorological setups were not favorable to push that smoke down to the surface. It was something that we were watching closely, but the weather patterns just never favored that push from the upper levels of the atmosphere down to the surface that would have brought smoke down to where people live. In early 2023, we did have our first air quality alert since 2021, and this was for a winter stagnation event. Winter stagnation event basically is just a period of very calm and cool conditions in the winter. In this case, it was winds less than 5 miles an hour, not only at the surface, but all the way up several kilometers into the atmosphere. When that happens, the pollution from cities and from cars and from other sources will sit basically over cities and not move and build up. And that will cause air quality impacts. And in this case, actually generated red or unhealthy for all air quality. In addition to the stagnant conditions, this storm was aided by the blue blizzard, as it's known in northern Minnesota, and the big mess, as it's known in central Minnesota. That storm caked a bunch of heavy, wet snow onto trees, and as a result, there's a lot of moisture available in the lowest 100 feet or so of the atmosphere. We call that the boundary layer, and that saturated boundary layer by the snow melting, especially when it was up away from the ground into trees, really helped elevate this to a red event as opposed to orange. This was the worst stagnation event that we've had in Minnesota since 2005, and the worst that we've seen at PCA since we've been forecasting since 2011. High impact event, and you can see here we added the red to the map. We were expecting red conditions, and here's our original forecasted alert map as it went out, and here's how it ended up being observed. It was kind of a strange meteorological setup where we had kind of two bullseyes, one near Fargo Moorhead and the other one in the Twin Cities, and then kind of a very narrow area of orange where there was a frontal boundary kind of parked across central Minnesota. So this is how it shaped up. Again, worst stagnation event we've had. We do get these from time to time, but it's very rare for them to have red or higher AQI. Pivoting now to what's coming in the rest of summer 2023. The first thing is that we have a bunch of new AQI tools coming to our website. First is a new current conditions webpage. This will be, again, a geographic information system or GIS enabled map. It'll work on phones, it'll work on desktop devices. It updates automatically every hour and has the EPA's nowcast AQI, which is the colored areas, the contours, and then it has the individual air quality sensors from Minnesota Pollution Control Agency as well as surrounding states. The map is fully interactive. You can click and toggle and get the current AQI as well as the primary pollutant and the concentration. Again, this will automatically update and conforms to accessibility standards that the state has. We also are changing our GIS based forecast for our day-to-day AQI forecasts. These forecasts cover day 0 through day 2, which is today, tomorrow, and the day after tomorrow. This is an example here of an AQI day with all the different colors on the map. The ones on the right are more likely to be observed. It's rare that we get all the colors on the map, but this map, again, is fully interactive. You can scroll and click it and get the information about what the forecast is, the primary pollutant, and the concentrations of both. Again, it goes out for all 3 days and it covers the entire state. It's no longer just select cities in the state of Minnesota. We've also moved the forecast discussion to be front and center. It'll be at the very top of the web page, and we've sectored out the discussions for day by day. This allows our forecasters to give a more nuanced and in-depth view of the weather and discuss any issues that might be occurring or any concerns that the forecaster has. This will be broken out so that a discussion can be for all 3 days, or it can be broken out day by day, which allows the forecaster to give more insight into a particular meteorological setup. And it's a great way to kind of get more information out to the public than what they can get just on the basic map. Here's a comparison of what this new map will look like compared to the current soon-to-be legacy website map. You can see the current one does not have any interactive features, and it only has certain cities there. This new air quality map will cover the entire state and will be interactive. The URL on MPCA's website will remain the same. It's just we're going to flip out the content. The go live will be sometime between May 15th and June 1, 2023. The forecasts are no longer based on cities. They're based on zones of counties, so chunks of counties across the state. And we did that so that we can issue a forecast and cover the entire state, not just for specific cities. Finally, the Minnesota MN Aware app is being discontinued effective January 30th, 2023. The MPCA is pivoting to the EPA Air Now mobile app, which is developed by the EPA and maintained by the EPA. That app allows for air quality alert information to be sent directly to the user's location. It can generate push notifications for that specific user location in a way that the MN Aware app cannot. There will be more information coming about this, but basically we'll sunset that app, and by the end of June, it'll no longer be usable, and we'll have everyone switch over to the EPA Air Now app, which has all the official data from MPC and surrounding states that get reported to the EPA. Finally, we're going to talk a little bit about the 2023 forecast and the outlook of what the air quality impacts might be in Minnesota. In 2022, I had already talked a little bit about the rapidly developing and expanding drought. We had extreme drought conditions in portions of the Twin Cities in the southwest Minnesota. Due to the record-breaking snowfall over much of the state, that area of drought has been cut back quite significantly. There's still a small area of moderate drought in far southern Minnesota with abnormally dry conditions across western Minnesota. This is a big improvement from the drought situation in 2022. And with less drought conditions means it's less likely to have a significant fire start and maintain here in Minnesota. Looking beyond just the current drought situation, there's basically an equal chance that drought would either get worse or persist. Equal chances of temperature are expected, so about an average temperature expected in June, July, and August, as well as equal chances or average amount of precip expected across the upper Midwest in June, July, and August. Again, this would favor a basically gradual increase of fire conditions towards the end of summer, but overall not seeing a lot on the horizon that would give us great pause. The Drought Monitor forecast from the Climate Prediction Center indicates that the drought removal is likely to occur in southern and southwestern Minnesota. But you can see on the map the areas in brown are drought persisting areas, and the source region from summer 2022 for fires, northwestern US as well as the southern plains, those remain in play, and we're likely to have the same type of haze impacts in 2023 as we did in 2022. This next series of maps are generated either by the National Interagency Fire Center, so the Forest Service, or Natural Resources Canada, and they cover the fire potential for either Canada or the United States. You could see that in May of 2023, a normal fire potential is expected here in Minnesota, but an above average fire potential is expected into Canada. It should be noted that all of these outlooks have a below average or very low confidence interval with them, and that has to do with the switch from El Nino, or La Nina rather, into an El Nino pattern. And that transition can sometimes bring unpredictable areas of drought, expansion or contraction, and precip. And so these are lower confidence forecasts than normally, but it's still good to note that, again, in May rather, we're not expecting much here in the US for fires, but across the border there could be. June, they are calling for an above average wildland fire potential, and this again goes back to that La Nina to El Nino transition. There's the possibility of the more variable jet stream, and we could have some areas that don't get any rain for a while. And with the green up just now occurring, this means that there could be a risk for wildfire here in Minnesota and the upper Midwest. The well above average and above average in Canada on the left is being driven by the persistence of drought in the western part of Canada. Again, these are lower confidence forecasts. At least that's how the discussion from National Resources Canada framed it. But something to definitely keep an eye of as we go into June, that there could be local fire impacts, which would then bring air quality and smoke impacts to Minnesota. July, we could see a normal and again, a slightly above normal fire risk in Canada and the United States. This would something you have to watch carefully because that a well above average just clips the northwestern part of Minnesota. And this was the area of Canada where we had many fires in 2021 that created our smoke impacts. And finally, in August, you can see on the Canadian side, the well above average is now right next to Northwest Angle in far northern Minnesota. On the US side, the US Forest Service is still calling for a normal wildland fire risk, but something to watch carefully. Fires can form either in northern Minnesota or southern Canada. The smoke plumes can impact a large portion or all of the state and could create some sort of air quality hazards that we'll be careful to watch for. So the forecast for 2023, because the drought conditions have dramatically improved, that would help temperatures kind of equalize a little bit, and we're expecting ozone impacts. Uh, Usually we have 1 to 3, which is a little bit below average air quality alerts for ozone. And we're calling for that just because summer temperatures are expected to be about average. And with the drought conditions being removed, there could be some warmer days, but again, it's kind of a wash in terms of what we'd expect, basically an average ozone season. I also want to point out that areas that are most likely to see ozone impacts are actually the suburbs of the Twin Cities and areas outside of Rochester. A lot of people think that the inner parts of cities are the ones that have the worst air quality impacts. But for ozone, it's actually the suburbs, areas away from the urban cores that have the worst ozone impacts. And that is because those volatile organic compounds are created inside the city and then they kind of diffuse out into the suburbs. And there is where they'll interact with sunlight and then convert from those VOCs into ozone. So, watching very carefully with that in those warm summer days, the Twin Cities suburbs, and again, areas right outside of Rochester, are areas that most likely see this type of impact in summer. And we're expecting an average season for that. Wildfire risk is higher in Minnesota in June, with an average risk for the rest of the summer. The local fire risk is reduced, at least outside of June here in Minnesota. And really, these maps should be underpinned with low confidence. That's the caveat with this. Uh, we'll be definitely monitoring for any sort of impacts, but because we're switching from a third-year La Nina into a strong El Nino pattern, the teleconnections, which is the bridge between those phase shifts and how it actually impacts local variable weather, is somewhat of a question mark. It's lower confidence than we'd otherwise see, and so something to definitely watch. Uh, but it's hard to say with any sort of certainty what will happen. The southern plains and the northwestern United States will again be in play for fire, and so there may also be some smoke impacts. Again, we saw that in 2022. That smoke stayed elevated and stopped ozone formation, but if we can get a meteorological setup that would favor that to get to the surface, we could have smoke impacts here in Minnesota. So with that, I thank you for your attention and for watching this presentation. Here's my contact information as well as the contact information for the entire AQI team. There's several of us on the team, as well as Hannah, the communications person who works with the AQI team. Again, thank you for attending, and now we'll switch it to question and answer.